This lesson is on the introduction to logarithms. In this lesson, you are going to learn to convert logarithmic expressions to exponential expressions and vice versa, and we're also going to learn how to evaluate logarithmic functions. We're going to look at Learning Target 2.4. I can convert logarithmic expressions to exponential expressions and vice versa. What is a logarithm? If b is greater than 0, which means b must be positive, b cannot be 1, so it can be any positive number except for 1, and x must be greater than 0, which means x also must be positive, then a logarithmic function is a function of the form log base b of x is equal to y. If and only if the exponential form b to the y is equal to x. These two forms, logarithmic form and exponential form, are equivalent. So the logarithm log base b of x is equal to y is equivalent to b to the y is equal to x. This is your definition of what a logarithm is. Notice that b, which is the base, must be positive and cannot be equal to 1, and x, which is the number, is going to be a positive number. It has to be greater than 0. These two things are very important. The base must be positive and cannot be 1, and this x must be positive. Base is b. The exponent is y. Let's look at this one where you're familiar. b is the base. Y is the exponent. When I raise the base to that exponent, I'm going to get this number x. This means the same thing. Log base b, which is the base, raised to this exponent is going to equal this x. So remember, b is the base and y is the exponent. What this means is that every logarithm that you see, log base b of x, is an exponent. This is just another way to write an exponent. It's a very unusual way that you're not used to seeing. You're used to seeing your exponents written this way. B to the exponent y is equal to x. Log base b of x is also an exponent. So remember, a logarithm is an exponent. What we're going to do next is convert logarithmic expressions to equivalent exponential expressions using our definition. So here's the first one. What I'm going to do is I'm going to always start with the base. Now this little process that we're going to look at next we call Loggy Froggy, which is a funny little name that we've given to this. It's not very mathematical at all, but it helps us to remember kind of what's going on here. We're going to take the base 3. We're going to jump across the equal sign and pick up the exponent, because remember, a logarithm is an exponent. So 3 to the 4th power is equal to 81. And when we write that down, that will be our equivalent exponential form. 3 to the 4th power is equal to 81. Let's look at another one. Start with the base 2, jump across the equal sign and pick up the exponent. 2 to the negative 3 is equal to 1/8. 2 to the negative 3 is equal to 1/8. Let's look at a third one. We're always going to start with the base. 10 to the 2nd power is equal to 100. Let's look at a fourth one. always start with the base. 5, go across the equal sign, get the exponent, to the negative 3 power, jump back across, is equal to 1/25. I'm sorry, 1/125. The fifth one, always start with the base. 27 to the 1/3 is equal to 3. Okay, now let's look at what all those look like. 3 to the 4th equals 81. 2 to the negative 3rd equals 1/8. 10 to the 2nd equals 100. 5 to the negative 3rd equals 1/125. 27 to the 1/3 equals 3. This is changing from our exponential form to, oh, I said that backwards, from our logarithmic form to our exponential form. All right, now let's go from exponential to logarithmic form. So here is 9 squared equals 81. So what we're going to do is we're still going to start with the base of 9. We're going to write log base 9 of 81 equals 2. The second one, we're going to write log base 5 of 625 equals 4. Number 3, we're going to write log base 12 of 144 equals negative 2. Number 4, log base 10 of 100 equals 2. And number 5, log base 5 of the square root of 5 equals 1/2. Now let's look at those written down. Log base 9 of 81 equals 2. Notice that the logarithm is equal to the exponent. Log base 5 of 625 equals 4. Notice that the logarithm is equal to the exponent. Log base 12 of 144 equals negative 2. Notice that the logarithm is equal to the exponent. Log base 10 of 100 equals 2. Again, the logarithm is equal to the exponent. And log base 5 of the square root of 5 is equal to 1/2. The logarithm is equal to the exponent. Now, the common logarithm is whenever we have a logarithm with base 10. Okay, it looks like this, log base 10, and it's called the common logarithm. We usually write the common logarithm without actually writing the base. So if you see y equals log x, that means that the understood base right here is 10. So this would be 10 to the y is equal to x. The common logarithm is written without the base. It's an understood 10. The natural logarithm is the next logarithm that we need to look at. The natural logarithm. I hope you will remember that e, which is Euler's number, is about 2.71828. A logarithm with base e, or log base e, is called the natural logarithm, and it is also written without the base. We cannot use log, so we use ln for a natural log. Okay, this comes from the Latin, which is logarithmus naturalis. That's why it's ln instead of nl. Okay, so this is y equals the natural log of x. This means the base is e. Whenever you see ln and no base, the base is understood to be e, which is 2.71828. So to change this to exponential form, I would have e to the y is equal to x. Now we're going to convert each exponential expression to a logarithmic expression and vice versa. using our common log and our natural log. This is log. Base is understood to be 10. So this is 10 to the second is equal to x. This one is ln. That's the natural log. The base is understood to be e. So e to the third is about 20.0855. This is an exponential with e in it. So if we wanted to write this in logarithmic form, we would say ln, the natural log of x, is about 4. This is an exponential expression with a base of 10. If we wanted to write our logarithmic expression, we would say log of 1 million is equal to 6. So this one is 10 squared equals x. This one is e to the third equals about 20.0855. Oops, I'm sorry. I went too far too fast. This one is the natural log of x is equal to 4. No e is necessary here because we used ln. And this one is log of 1 million equals 6. No 10 is necessary here because we used the common log, log. All right, so let's evaluate these. The first thing that I'm going to do here is I'm going to rewrite this logarithmic expression as an exponent. 19 to the x equals 361. Same thing with this one. I'm going to say 1/7 to the x equals 1/49. Same thing with this one. X to the third equals 216. Number 4, 3 to the 0 equals x. And number 5, 9 to the negative 2 equals x. Once I have written these in exponential form, I'm going to solve the exponential equations just like I did earlier. X to the negative 1/4 equals 1/2. I left that one off. I apologize. All right, so let's look at each of these. 19 to the x equals 361. Hopefully you will know that the next thing you have to do is get your bases the same here. 19 squared is 361. Then I can set the exponents equal to each other, so x is equal to 2. Here I'm going to say 1/7 to the x equals 1/49. 1/7 to the x equals 1/49. Hopefully you can look at this and say, well, 1/7 squared is 1/49, so x is equal to 2. For number 3, x to the third equals 216. So hopefully you know that 6 to the third is 216. So now I can say x is equal to 6 because 6 to the third is equal to 216. So what number to the third is 216? That would be 6. Here I can say 3 to the 0 equals x. And hopefully you know that any number to the 0 is equal to 1. So x here is equal to 1. 9 to the negative second equals x. Hopefully you can say, well, 9 to the negative second, that means the reciprocal of 9 squared. 9 squared is 81, and the reciprocal of 81 is 1/81. X to the negative 1/4 equals 1/2. X to the negative 1/4 equals 1/2. Hopefully you will realize that this means the reciprocal of x raised to the 1/4 equals 1/2. That would be 16 because the 1/4 means the fourth root of some number is equal to 1/2. Well, the fourth root of 1/16 is equal to 1/2. Then you take the reciprocal of 1/16 to get 16. Learning target 2.5 says I can evaluate logarithmic functions in a real-world scenario. A solution's pH is given by the function p of t equals the opposite of the log of t. Notice this is the log, L-O-G. There is no base, so this is log base 10, the common log, where t is the hydronium ion concentration in moles per liter. A sample of coffee has a pH of 5.0. What is the approximate hydronium ion concentration of the sample? Well, the first thing that I'm going to do is take the formula that they gave me in the problem. P of t equals negative log of t. Common log. Notice that this has a base of 10. Then I'm going to replace P of t, because that stands for the pH, with the pH that was given to me in the problem. That's 5.0. Then I'm going to divide both sides by -1 so that I can get rid of this negative in front of the log. So we're going to divide by -1 and get -5 equals log of t. Now this is base 10, so I'm going to change this from log form to exponential form. And I'm going to say 10 to the -5 is equal to t. Now I'm able to just type that into the calculator and find out that t is 1 times 10 to the -5, 0.00001 mole per liter. That is the hydronium ion concentration of the sample. In the next example, we're looking at the wind speed s in miles per hour near the center of a tornado, and it is related to the distance d in miles that the tornado travels, and if this is given by the equation s equals 93 log d plus 65. On March 18, 1925, a tornado whose wind speed was about 280 miles per hour struck the Midwest. How far did the tornado travel? The first thing that you're going to do is write the formula that was given to you. S equals 93 log d plus 65. Then you're going to substitute the miles per hour, 280, in for s. That's the wind speed in miles per hour. Next, we're going to subtract the 65 from both sides and get 215 equals 93 log d. Now I'm going to divide by the 93. 215 divided by 93 is equal to the log of d. Notice this is the common log, L-O-G. I'm now going to change that to exponential form. 10 to the 215 divided by 93 is equal to d. Now I can type that into my calculator and find out that the distance that the tornado travels is approximately 205.03 miles.